Module 3, Frequency Distributions and Summary Statistics. Let's consider how data for a single variable can be made sense of. There's two primary ways we can do this. One is through a frequency distribution, and the other is by using summary statistics. Let's look at frequency distribution first. We have here a set of grades for my Sociology 1013 students last semester. Obviously, they're letter grades. How would we make a frequency distribution for this particular set of data? First, we would determine and list the various grades, the attributes for the variable. The attribute is grades, and of course then the letter grades, precise letter grades, would be the attributes. So we have A's, B's, C's, D's, and as you can see also there's F's within the distribution. The next step is to then determine how many grades of each category there are. So let's count the number of A's. Appears to be 3. The number of B's. Looks like there's a few more than that. 5 precisely. C's. Looks like there's 7. How many D's do we have? 1, 2. Looks like 3. And for F's we have only 2. Okay, so far so good. So we have the grades listed, and then we have the frequencies for each letter grade within that distribution. Now, really to be complete, since we have 20 grades here, it is best to get some idea of the proportion of each grade, right? The percentage of each grade. And so we would also, in a frequency distribution, commonly calculate the percentage of each grade. So we divide, of course, the frequency for a particular grade by the total N, or the total sample, in this case 20. So we find that 15% of our students had A's, 25% had B's, 35% C's, 15% D's, and 10% had F's. We had 100% of our sample accounted for within this distribution structure. So what does that tell us? Well, consider where we are here, this jumbled mess up here, as opposed to this fairly ordered distribution here. We see that precisely 15% of the students received A's, 25% B's, and so forth. We can say, make some generalizations, that 40% of the students were performing pretty well in the class by virtue of making A's and B's. On the other hand, we can say that 25%, 1 out of 4 students, weren't performing well by virtue of their performance in terms of D's and F's. And we can say that about a third of the students were performing at a kind of an average or C level. So we can see this with this frequency distribution, certain patterns that would otherwise obviously be quite impossible to determine by simply looking at those random grades up here. Let's look at another example of frequency distributions, and let's take the reported weekly income last semester for my Sociology 4973 students. And so we have these various money amounts reported by my students. And so first of all, we would of course list the precise income amounts. So we find that we have, of course, a student here, 2 students actually making no income. We find that there was at least 1 student, actually 2, making $10, and so forth. And so we just list the amounts out there in terms of the attributes for the variable income. And I believe we find that $200 is the maximum amount of income earned per week by any students. And now, of course, we attach frequencies to these income amounts. And we find that 2 students earn 0, 2 students earn $10, 1 student reported earning $25, and so forth, all the way down to 200. 3 students reported earning $200. Not a bad income per week, for students at least. And we had 17 total students in the sample. Now, again, we want to get some sense of the distribution in terms of proportionality. And so the next step, of course, is to calculate the frequency or the distribution in terms of proportions receiving given amounts. And so we find that about 12% made no income, another 12% only made $10, and so forth, all the way through the distribution. We calculate the proportion making a given amount. We find that if we look at $100, we find that $100 and above, we find that roughly, 35 and then 17, a little over half made $100 at least. And a little under half, of course, a little under half made less than that. Almost a quarter of the students hardly made anything, didn't make anything at all, or hardly anything at all. Represented here in this almost 24 students, 24% of the students. Okay, so that we can see that these frequency distributions do help us very much in making sense out of rather disorganized data, that which we have up here. They are quite acceptable for describing some data distributions. However, what if we have many attributes for variables, for our variable? Or what if the sample size is very large? Frequency distribution would be really quite difficult under either of those conditions to enable us to really make sense of the data. And so what we do is we turn to descriptive statistics or summary statistics. And there's 2 basic kinds we'll talk about today. Measures of central tendency, that is to what extent does the data kind of cluster around given points within, to what extent is it centered. But we also have measures of dispersion, so that would give us an idea about how far it's laid out, how it's dispersed across the distribution. We'll consider 3 basic measures of central tendency, all of which I'm sure you've calculated before and you're very well aware of what they involve: the mean, median, and the mode. And then there are 2 basic measures of dispersion, the range and standard deviation. But for the sake of simplicity, I'll just employ the range. The standard deviation is a bit more involved in terms of calculations, so we'll just look at the range. Measures of central tendency. The mean first. How do we calculate the mean? Simply, we sum all the values by the frequency that they appear, and then we divide by the total n, or the total sample size. Okay, so we sum all the values by frequency and then divide by total n. So, going back to our reported weekly income for Sociology 4973 students, we have the attributes for income, we have the frequency for each of those attributes, and so we would calculate the sum per attribute, frequency by income amount in this case. We find that the first is 2. 0 times 2 equals 2. 10 students, 2 students made $10, so that's a total of $20, and so forth, all the way through the distribution. 4 students reported $100, that's $400. And again, 3 students reported $200. And then we sum those amounts. We simply add those amounts up, and we come up with a total amount of income for our class, about $1,500, $1,515 specifically. So, what do we do next? We, of course, divide this $1,515 by the number of cases in our population up here. And that comes out to $89. So that would be the mean for our students in that particular class, at least reported by them. Not to say that they're necessarily reporting their true incomes. Okay, well and good. The median is found by arranging the attributes hierarchically. I like to do it from highest to lowest, or you could go from left to right. But you arrange the attributes by frequency hierarchically, and then select the attribute at the midpoint of total distribution. Now, I know that may sound a little strange, but as we get into it, it'll make more sense. So if there were 21 cases in our total sample, the attribute value for the 11th case in our order would be the median. Okay, so let's go back to our final grades for Sociology 1013 students. We noted the grades. We arrange these grades, of course, in order. There's a hierarchy here, A, B, C, D, F. And then we find, of course, the frequency for each of these grades, 4 A's, 5 B's, and so forth. The question now is, what is the median? Well, the median, of course, is found by going to the middling value. We have 21 cases, and alt. Our n is 21, so what would be the middling case? And you can find that by finding the one in the middle, which would be 21 divided by 2, and then rounding up to the nearest value would be the 11th case. And let's count down then to the 11th case. We have 4, 5, that would be 9 altogether. And then we have 7 C's. So in this case, the median would be a C, right? Because the 11th case is within this particular category. 9 students here, and then, of course, 7 here, and that 11th case would be among those. So far, so good. Let's go back to our reported weekly income for Sociology 4973 students. As we found it before, we found a mean of $89 per student. But what if we add 2 more students? They come in late to the class. And so I asked them, hey, we're doing a little study here, and we want to know what's your weekly income is. One student reports $10. Another student reports $5,000. Wow. Pretty good income. I wonder what they're doing to make that kind of income. So what would we find now in terms of our mean? If the old mean is 89, by adding these two new cases, we find that our new mean is now $343. Wow, we've really jumped up, right? From less than $100 to more than $300 per student. Now the question has to be asked, is this a problem in terms of using the statistic? You know, we're interested in describing the data and seeing how the data cluster around some point meaningfully. Would it be appropriate to say that our average student in the class makes $343? I don't think so. I don't think that makes much sense. That really distorts the true picture of data distribution within the class. So that's where the median would come in, particularly where there's these large outliers, or a large outlier, which would really give a false impression as to the actual distribution. So let's calculate then the median. So what would the median be? We have 19 cases. So what would the middling case be? We have 19 cases. The middling would be what? Of course, the middling case would be the 10th case. And so we would count down to the 10th case. We have 5, 6, 7, 8, 9, and we have 4 here. So the 10th case is really right in here, right? Although we have 4, that 10th case lies in here. And so the median would be $100. Oops, I slid off that maybe a little too fast. So you can see the median is $100. And of course, that $100 would give us probably a far better picture of the actual distribution of income as opposed to the $343. It would give us a better sense of really the distribution of income. So when we have these large outliers in particular that would distort the data, the median really comes in handy. Another measure of central tendency is the mode. And the mode is simply that variable which occurs most frequently in a distribution. And so what is our mode within the final grades for my sociology 1013 students last year? What is the most frequently occurring grade? And the way we've got it laid out already here in the frequency distribution, we can see that the most frequently occurring grade is a C. 7 students received a C. So the mode is a really easy statistic to determine. It's simply the most frequently occurring value. Measures of dispersion, and again I'll simply look at the range rather than the standard deviation. The range involves the identification of the highest attribute and the lowest attribute found in the distribution of data. Okay, so it's the highest and then the lowest. That gives you the range. And so what would be our range in this collection or distribution of data? And again, we've got them arranged. And indeed, we find that we do have students receiving an A, and we do have students receiving an F. And so our range is A to F. Now, let's say we don't have any students, God forbid, that make an A. So instead of 3, we actually have 0 A's. Of course, then our range would be B to F. So again, simply the highest where there's an actual case to the lowest attribute where there's an actual case would give us a range. Now I'm going to do something that I think you'll enjoy. And then let's turn to some example problems. And this is where also level of measurement comes in as we look at these example problems. I ask you the open-ended question, what is your favorite type of ethnic food? What kind of food do you really, really enjoy of an ethnic variety? And I find the following distribution. 1 student likes French, 8 students soul food, 3 students German, and so forth, all the way through those various foods. And of course, I'm interested in calculating certain statistics with this, so I note the frequencies. Okay, so what's the variable of relevance here? What would you say the variable of relevance is? Could we call it just favorite type of ethnic food? I think that would be relevant, a relevant title. And then the attributes would be the various kinds of ethnic foods, right? Okay, so the variable of relevance is favorite kind of ethnic food. What is our level of measurement? Is it nominal, ordinal, interval, or ratio? What do you think? Well, if you said nominal, remember nominal relates to differences in kind, you'd be correct. This is at the nominal level of measurement, because there's no sense of quantitative, there's no quantitative sense at all to this data. There's no more or less than, for example. So our level of measurement would be nominal. Can we calculate a mean? Well, we can't even arrange these in any order, of course. And there's no real zero, and there's no multiplication. Can we calculate a median? Well, if we can't order them, how do we calculate a median? How about a mode? Can we calculate a mode? Remember, the mode is the most frequently appearing attribute or value. And of course, we can calculate a mode. We find that most, or at least the greatest share of students prefer Mexican food. 50s are mode. Now, is there a range? Well, again, it's qualitative, right? It's apples and oranges. And so range makes no sense. We can't order these in any way. And so, again, we have no range. All we can calculate with nominal level data is the mode. Let's look at another example. Spurs season will be starting in about another month. That's going to be exciting with the new acquisitions in particular. And so a survey asks San Antonio residents, for this coming season, where will the Spurs finish? When all is said and done, where will they finish? And we find the following answers. 30 residents say that they're going to win the championship. They're going to finish first. 8 residents say that they're going to finish second by virtue of losing in the finals. They're going to get to the finals, but they're going to lose. 44 of our residents are a bit more pessimistic about our team this year. They're not going to even get to the finals. They're going to be eliminated somewhere in the playoffs. Okay? I hope it's not like this past season where they were eliminated in the first round. And then there's some folks that are incredibly negative and say they're not even going to make the playoffs. You know, Western Division, pretty hard. Not even going to make the playoffs. 9 people say that. Okay, so what is the variable of relevance here? Well, of course, the variable relates to projections or estimates of where the Spurs will finish. And these are the attributes, of course. First, second, eliminated prior to finals, not make the finals at all. What's the level of measurement? Is it the nominal level or qualitative, the nominal level, or is it a quantitative kind of variable? And I think you can probably see that whenever we talk about such things as place or position, we're really talking, we see an order here, right? The best one can hope for is to win the championship, if not the championship, coming in second, or maybe being eliminated somewhere in the playoffs before the finals. And of course, the last category would be not make the playoffs at all. So there is an ordinality here. Now, there's no pointing ordinality out. We can ask, is there equidistance between these attributes? Well, we don't know exactly what position they're going to wind up in if they make the playoffs but are eliminated prior to the finals, right? Could be in the semifinals, could be in the quarterfinals. So, and we don't know either where they would finish up if they didn't make the playoffs altogether. So really all we can talk about is the ordinal level of measurement. Now with the ordinal level of measurement, we cannot calculate, there's no zero, and we can't speak of multiplicatives either, of course. And so we really can't calculate a mean. Can we calculate a median? Is that possible? How many cases do we have here? 38, 44, and 9? Can we find that middling case? I can't do the math in my head right now. Where would our middling case be? Just by eyeballing the data, I bet our middling case is right here, eliminated prior to the finals. So that would be the median. What's our mode? Our mode, of course, would be the most frequently occurring attribute, which would be eliminated prior to the finals. These fans, I tell you, are not optimistic at all, are they? What is our range? The highest, of course, would be to win the championship. The lowest would be to not make the finals, or not make the playoffs at all. So that would be our range. Responses to survey question asked to wage-earning respondents, how much money do you earn per hour at your current main job? And for the sake of simplicity, I've simply rounded it to the nearest dollar. What's our variable of relevance? What would you say? Earnings per hour for students. What's the level of measurement here? It certainly goes beyond the nominal level, right? Obviously, we're not talking about apples and oranges. We've got precise dollar amounts. We've got more or less than. We've satisfied equidistant attributes. And really, we also satisfy the criteria for the ratio level of data. It would be possible, I guess, to not earn a wage at all if one was working. Maybe we're playing with words here in terms of semantics, but it certainly might be possible to make $0 per hour, although, of course, totally unlikely. And there's multiples also, in the sense that, for example, we have a person here making $5, and they're making half as much as that person making $10. And then that person making $5 is making 1/3 as much as that person making $15. Okay, so the level of measurement I think we can decide on is ratio. Is there a median? Yeah, again, we would have to actually develop a hierarchy here, right? Create a hierarchy and then find that particular value that's in the middle. I haven't done it, so I'll leave it up for you to do. Arranging at the highest level 15, 14, 11, and so forth, all the way down to the lowest level. And our middling value would be the median. What's the mode? What's the most frequently occurring value? Just eyeballing the data, it looks like what the mode might be $9. We have 3 students who are making that amount. And then finally, what about the range? Again, identify the highest amount and then the lowest amount, and that would be our range. Okay, that was pretty easy, wasn't it? Now let me throw you another example, which may not be so easy. You know, the lottery, Texas lottery. I don't know if you've played it or not. It used to be very, very popular, widely played among Texas residents. At any rate, the 10 most frequently selected Texas lottery numbers. You know, each ping pong ball has a number painted on it. And we're looking at data for 2010. And so we're looking at the number of the 10 balls with given numbers that were most frequently selected during that year. They have lotteries, I think, on a weekly basis, the big lottery. And so what 10 balls were most frequently selected? So the variable of relevance would be what? The most commonly selected lottery balls, right? The numbers of the most commonly selected lottery balls. What would be the level of measurement? I'm not going to tell you that one. I'm going to let you try to figure that one out for yourself. I'm also going to let you figure out what the mean would be, what the median would be, what the mode would be, and also what the range would be, okay? I'll be interested to find out what you come up with in regard to these answers to these 5 particular items. Okay, that's about all I wanted to talk about with regard to these matters. So let's end it here.